Okay, now we record our lecture. Okay, we started from the electrophilic aromatic substitution. Now, today we start with the reaction of benzene compound. Okay, Talaba. Now, if you have benzene as starting material, any compound you can get from this starting material. Now, or in another word, this benzene ring, it will be useful for any reaction. It will be enter any type of the reaction. Here's the meaning. Now, for example, I will give you an example. If you have benzene, you can convert the benzene to the toluene. Okay? You can convert the benzene to the aniline. You can convert the benzene to the benzoic acid. Okay, like this, for this example. Now, and here, look to the name, electrophilic aromatic substitution. Substitution meaning replacement. Okay, that meaning we will remove the hydrogen and put the electrophile. Okay, the electrophile. Aromatic substitution, that meaning the replacement, the hydrogen by the electrophile, it will be happened on the aromatic cycle. Okay, here the meaning here, the electrophilic aromatic substitution. And he said here, based on the structure and the properties, what kind of the reaction should be benzene undergo? We say that the electrophilic substitution reaction. Why? Because the benzene has 6 pi electron delocalized in the 6p orbital that overlap above and below the plane of the ring. This loosely held pi electrons make the benzene ring electron rich. Now, look to the benzene ring. The benzene ring is electron rich or electron poor?
Rich.
No, it will be electron rich. Yeah, because we have 3 pi bond. Yeah, that meaning we have 6 excess electrons. They are delocalized over the ring. Okay, Talaba? Now that meaning the benzene is electron rich. That meaning if we say the electron is electron rich, that meaning it will be react with electrophile or nucleophile? No, it will be exactly react with the electrophile, exactly. Okay, that meaning be careful here, because the benzene ring is high electron density. That meaning it will be react with something with part electron deficient. Okay, that meaning it will be react with the electrophile. Here the meaning. Now, we said that before that the benzene doesn't undergo addition reaction like other compound. Then, if I say to you, you have benzene and react with X2, okay, react with S2, don't make addition reaction. If you make addition reaction like that, it will be big mistake. Okay, it will be error. Now, the benzene, it will be under substitution reaction by replacement 1 hydrogen by electrophile. Okay, this. And the mechanism, Talaba, the mechanism for the electrophilic addition reaction, it is the same mechanism for all the electrophilic reaction. Now, I think also it is easy if you compare the electrophilic addition mechanism with the like SN1 or SN2, elimination 1, elimination 2, it will be the easy one. Okay, the easy one, because it will be the same over all the reactions. Okay, yani we said overall the halogenation, acylation, alkylation, like that. We will take the reaction one by one. Now the mechanism in general, it will be like this. Look, we have the addition of the electrophile, step number 1. Look, addition of the electrophile to form what? Carbocation. Now, look, if we open this pi bond, okay, it will be attack the electrophile. That meaning here we have, it will be a positive charge confirmation. Look here, when we have positive charge, yes? Now, this positive charge, in your opinion, it will be stable or no?
No, not stable.
Why?
Because تحتاج يعني لا راح تسوي باي بوند.
Secondary يا سيدو ما نبي tertiary بتندو.
Yes, tertiary, it is the most stable carbocation. I know, it is the highest one, I know that. But we said before that if you have negative charge or positive charge and you have resonance structure, Okay, or resonance structure. That meaning the cation or the anion, it will be stable. Now,
Stable.
look, we have resonance here or no? Yes, we have resonance. This double bond, it will become to here, and the positive, it will be converted here. And also double bond come to here, the positive. That meaning we have resonance here. Okay, resonance structure, we talked about that before. Okay, before I think in chapter number 1. Okay, now if you have resonance structure, the resonance make the anion or the cation stable. Okay. Now, also if you remember the carboxylate anion, do you know what meaning carboxylate anion? In chapter number 1, we will when we talk about acid and base, the conjugated acid, conjugated base, we have carbon, oxygen minus. Okay, why this carboxylate anion is stable? Because the resonance with the carbonyl group. If you remember that, here the same thing, because the resonance, that meaning the carbocation, it will be stable. Okay. Now look here, he said addition of the allytrophil from forum, forum, a new carbon E. This the carbon E. This the carbon E. The carbon E bond. Okay, bond using 2 pi electron. This both of the pi electron, it will be attack the allytrophil. Okay, it will be attack the allytrophil by using the 2 pi electron from the benzene ring and generation of the carbocation. This carbocation intermediate is not aromatic. Now this aromatic, no. Why? Because why it is not aromatic, Talaba?
P orbital سيدا مانا يخوليا.
Not conjugated. Not conjugated.
Not conjugated.
Not conjugated. Yes. We have, look here, double, single, double, single, single, 3 single. It is impossible to be aromatic. Also, if you calculate the pi electron, it will be 1, 2, 3, 4, not 6.
No.
Okay.
Not.
Yes. For this reason, not conjugated or not according to the Hacker rule. That meaning it will be not aromatic. Now, but it is resonance stabilized. But we have resonance, it will be stabilized. Okay. The 3 resonance structure can be. We have 3 resonance structure. 1, 2, 3. The positive here, the positive here, and the positive here. Okay. That meaning we have 3 resonance structure. The 3 resonance structure, it will be make the carbocation stable. Now, step 1, it is okay. Don't care about the rate of determination step. The reaction, the rate of reaction, it is not our subject. It is something advanced for maybe for master student, not for you.
Good.
بله.
يعني عم دليفري بو stability ديال ديف resonance يعني عم ديف carbocation نوتشي.
نعم. The resonance يا carbocation هردوكا. resonance يا carbocation همي secondary. هذا secondary وهذا secondary وهذا secondary. شو فرق نينا؟
أري.
Okay, that meaning don't say that we have rearrangement. أبناء rearrangement. سكفان.
درسته.
Okay, طلبة be careful. This it is not rearrangement. This resonance structure, not rearrangement. Okay, because this secondary also this secondary carbocation. لا معقولة secondary rearrangement دي بنا secondary rearrangement دي بنا secondary. هذا خلط. Rearrangement for carbocation will be happen if the primary convert to the secondary or secondary convert to the tertiary carbocation. Now we have just resonance here. This just resonance here.
سيدا محاضرة باري معنا كداك وشحنا موجب ليفل بيتاندي بدا كونجويتي.
ايه صح كي او شحناء it will be delocalized from here to here, just from here to here, not complete cycle. Okay, just from here to here. If the positive charge it will be completely conjugated on the cycle, it will be resonant, يعني it will be aromatic. Okay, do you understand that? Look, the positive it will be this carbon and this carbon and this carbon, not continuous again, just from here to here, just. Okay, that meaning look. تمام بوشي تمام نبي تنصحك فيري دبل بوند هيا فيري أبا فيري دبل بوند هيا
لا
إيه هكا دبل بوند نينا يتشاوى دبل بوند ديت فيري أوكي بله
سيدا ميكانيزم بو مجالك بزحمة بو ما بسركيم وفي درجي بيجا
Okay, no problem. I will, but it is clear here. I say to you, this is so easy mechanism. Okay, not like SN1 or SN2 elimination 2. This is so easy. Just you have the pi bond. One of the pi bond it will be open to attack the electrophile. Make positive charge. Positive charge delocalize here from here to here. Just from here to here. Okay. Okay, that is not something complex. Okay. Okay, I will make the chem office, no problem. Where is the chem office? Oh, look. Yes, this cycle, yes?
Yes.
Cycle or square?
Cycle.
Cycle, okay, now. Look, we have hydrogen here. Of course, we have hydrogen. Or I would, you know, all of them, we have hydrogen, hydrogen, hydrogen. It is not necessary to draw with the hydrogen now. Now, you have the electrophile, anything, electrophile. This is the electrophile, okay? This is the electrophile. Now, look, what will be happen? This pi bond, it will be open to attack what?
Electrophile.
This to attack the electrophile. Yes. Now look, if I say the pi bond it will be open from here, that meaning the positive it will be here or here.
وين جيرو
يعني جهه سريعا جهه بني.
انا ادرس هذا مش فارقه.
لا فرقه سقفان صح كي سهمه صح كي يعني درجه انه كوقت if you want to open the door it will be open from just one side not from the two sides.
تعجبني بردش بني كوربيكيشن ايه تبيتم تشارج
هاي عافيه وصل صح كي سهم از الفيري راوستم نال فيري سري اوكي يعني ابا فرقه طلبه وصل فرقه
ايه
اوكي now that meaning this pi bond it will be open to attack the electrophile and the positive it will be here. Okay, now I will make the positive this. Okay, and we have electrophile here. This is the electrophile, and we have positive.
سيدو بس بسيورك سر ملزمه تسهم جونك شو بودم چی تفزانین هيك بس حكي ملزمه
صح كملزمه او it is from the book. Okay, and if you're organic chemist and you read the general book for the organic chemistry, they think you understand everything. Okay, they think you know how the pi bond will be open. Okay, for this reason they will make just like this, just from here, just like this. Yes.
صار امتحان هذا بس معلومات تقولي ما انا دكتور.
Just I say to you, if you go to the organic books, when talk, they think you understand everything. For this reason, they make the arrow like this, just like this, small. Okay. But for the student, for the graduate student, no, it will be different. It will be must be like this. Okay. Now, again. Look, now what will be happened? We have resonance. The resonance we have pi bond here.
No.
Yeah. That meaning if you make for me like this it will be error. This it will be error. How there is no pi bond? How the arrow it will be go to the positive charge? Okay. This it will be big mistake. Okay. Now it will be reverse. Where's the pi bond? This is the pi bond. That meaning this pi bond it will be open to the positive charge. Open from here or open from here, Sagvan?
او جهة السهم جبري
سري
يا سري عافية أنا يا بني خلد. Okay, that meaning it will be open from here to the positive charge. Okay, now it will be like this. Okay, it will be like this. And this positive, yes, and this double bond. Tamam? Okay. Now this pi bond, it will be open from here or from here? No, it will be open like this, and this side. And this side, okay, impossible of this side. That meaning no. This
Yes,
error.
sir.
That meaning it will be from the up to the positive charge. Okay? From the up to the positive charge. That meaning our structure, it will be like this. Oh, positive, and we have double bond here. Yes? Now, we have double bond here to open in this positive charge?
No.
No. That meaning if we want to write the hybrid structure, our hybrid structure, it will be like this. What meaning hybrid structure, Sagwan?
hybrid. يعني hamira resonance pegva.
Hamir resonance pegva, عافية. يعني it will be, look, start from here to the here, yes? Okay, that meaning this. No, sorry. Where is? Okay, I don't know. Maybe it will be, yes, like this, and like this. All this, what? All this is positive charge. Okay, we have positive here? No, we don't have positive here. Actually, we have hydrogen here, but I don't draw the hydrogen, طبعا. This one of them, it will be hydrogen, and the other, it will be, this, it will be hydrogen, and the other, it will be allotrope. Okay? Okay. Now, what will be happen in the second step? In the second step, look, we have this. Look, the base, okay, the base or the negative part or the nucleophile part, okay, it will be attack the proton, and both the electron here, it will be open to make a new pi bond to reverse again the aromatic system. Okay, I will make here sharing. Look, for example, I will take this one. For example, I will take this one. Okay, this one, I will take this one. Now, we have hydrogen here. Look. Yes. If I say to you, I want to make aromatic system again, what will be happen? We have base here. Yes, we have base. Or we have nucleophile. Okay, we have nucleophile. What will be happen? Now, the nucleophile, talaba, this is the nucleophile. It will be attack the electrophile, or it will be attack the proton?
Attack a proton.
Attack the proton. This here, both of the electron here in this sigma bond, it will be converted to make a new pi bond. Okay, a new pi bond. يعني النتيجة دي بنتيجة النتيجة. This.
3 pi bond?
Yes, a 3 pi bond aromatic system again with the electrophile. With the electrophile plus what?
Plus HB.
عافية.
And attack the proton.
عافية. Easy, yes?
سهل يعني
Easy.
على SN1
Now, this is the general mechanism for all the benzene ring reaction. For the, I say to you, halogenation, acylation, alkylation, all the benzene ring reaction. This is the general mechanism, the same mechanism, there is no difference. Okay? The same mechanism. Now, here, look, we talk about this, how it will be converted exactly. Always, look here, say always draw in the hydrogen atom and the carbon bonded to the electrophile. That meaning Put the hydrogen here. Why? The hydrogen is necessary to draw here for the next step, for the step number 2, because the base or the nucleophile, it will be attacked this hydrogen, okay? It will be attacked this hydrogen atom. For this reason, draw it. You can draw it because you don't want to make mistake in your mechanism, okay? Notice that the positive charge, it will be have resonance structure. Always look at the leucolide. Where's the leucolide? Ortho and meta para, this. And finally, the hybrid structure, it will be give you here a 3 positive charge. We have 1, 2, 3 over all the ring. Okay, 3 positive charge. This is the hybrid structure. Okay, Sagvan, look here. When I draw the hybrid structure, I make positive here, yes?
Yeah.
But here he said partially positive, partially positive, partially positive. Sometime here, sometime here, sometime here. Okay. Okay, that meaning no different. If you want, you can make it like this. This structure told you the positive charge. Sometimes it will be in this carbon, and sometimes it will be in this carbon, and sometimes it will be in this carbon. Okay, that meaning on the ortho, this ortho, and this ortho also. On the para, this para. So on the meta, there is no positive charge on the meta. Okay, this here meta and this here meta position, there is no positive charge. Okay, where is the positive charge? The positive charge, it will be on the ortho, on the para.
Would you say this at meta, Nina?
أنا very I'm بستياب.
لا I said that would you change بيتن هيك أظن.
أنا موقع باي بوينت صح كي. Positive ortho. Positive para. Meta Nina very meta. Why? Because this pi bond, it will be open like this. Okay? It will be open like this. And the positive, it will be not here. It will become to here. That meaning on the meta here, there is no positive. Look, there is no positive. There is no positive. Okay? Because... Ciao, Sagvan?
بجم يعني او تشارجه في بوشي بهتا سر باي بوند وصانه چه بيدن
طبعا معنا باي بوند صح كي باي بوند when I say to you the pi bond it will be open, that meaning it will be open on from this side or maybe from this side. Anyone is based from this or from this?
Sorry.
No, from this, yes, sorry. That meaning the pi, it will be open from here. That meaning this carbon, there is nothing happen on this carbon. There is no empty p orbital. Okay, there is no empty p orbital. That meaning this positive charge impossible to come to here. Why? Because there is no empty orbital. The empty orbital, it will be here. It will be from the open side. Okay, it will be from the open side. I hope you understand this. Exactly, it is like the door. Okay, يعني وكي درجة. If you want to open the door, it will be just open from the one side, not from the two side. Yes? Okay. No. Inshallah. Now, look to the type of the reaction. For the benzene ring, we have the halogenation. Okay, we have the halogenation. This is the halogenation. We have X2, but we said it is not addition, talaba, not addition. That meaning we need catalyst. We need Lewis catalyst. This Lewis catalyst. Okay. That meaning if you say Cl2, this it will be FeCl3. If you say Br2, this it will be what? FeBr3. F3. Okay. Don't make this Cl2 and this Br. No, it will be the same. X, it will be the same up and to the down. That meaning if you use Cl2, that meaning it will be FeCl3. Br, it will be FeBr3. And replacement the hydrogen with one halogen, it will be give you what? It will be give you aryl halide. Aryl halide. Okay. Aryl halide. The second type of the reaction, it will be nitration. Nitration, that meaning replacement of the hydrogen by what? By NO2, nitro group, NO2. Nitro group طبعا طلبة NO2 nitro group is allyl also. It will be replacement by one of the hydrogen to give you nitropenzene. Nitropenzene. Now the third type of the reaction is the sulfonation. Sulfonation replacement of the hydrogen by what? By sulfonyl group. This sulfonyl group SO3H. SO3H. طبعا we used SO3 and strong acid. We have reaction between SO3 and the strong acid. Also we have reaction here between the nitric acid and the sulfuric acid to give you the neutronium ion. Also here we have reaction between SO3 and H2SO4 to give you the sulfonyl cation. It is like allyl, and the replacement, it will be happen between the hydrogen and the SO3H. Okay, the sulfonyl group. This halogen group, this nitro group, this sulfonyl group. And also we have a Friedel-Crafts alkylation. طلبة alkylation. What meaning alkylation? يعني alkyl group طلبة. That meaning we will replace one hydrogen by alkyl group. Methyl, ethyl, propyl, butyl. Okay. This RCl. What meaning RCl? Maybe this R CH3, maybe C2, CH3CH2, maybe propyl, maybe isobutyl. Okay, like this. That meaning replacement of the hydrogen by R group. The final one is the Friedel-Crafts acylation. Acylation طلبة, this is the acyl group. This is the acyl group. Okay. The carbonyl with alkyl, we said acyl group. This acyl group. Okay, replacement of the hydrogen by acyl group, and we will talk about all the reactions one by one, inshallah. One by one. The first one is the halogenation.
دكتور ديك على الستاج باركي.
طبعا. But يعني not يعني difficult. Okay, it is easy, I think, because all of them the same mechanism, all of them, and يعني لا كتسنياب زحمة شيء ساكي أو لويس أسيد تمام أو strong acid Lewis acid all of them or Lewis acid or strong acid. Okay, and if you say halogenation, that meaning halogen. Nitration, that meaning nitro, from the name. Sulfonation, sulfonyl. Alkylation, alkyl. Acylation, acyl. Yani, no, it is not something complex. Okay? Now, the first one is the halogenation. Look, in the halogenation, benzene react with Cl2Br2. طبعا in the presence of the Lewis acid catalyst. Why Sagvan with the Lewis acid catalyst?
the addition reaction شنو بدنا نسيتها موني
عافية صح كزغبان زيراكا. Okay, now such as FeCl3 and FeBr3 to give what? To give the aryl halide. Okay, like what? Like chlorobenzene, bromobenzene. Okay, now we cannot use the iodine and the fluor. Okay, why? Because the iodine, look, it is too unreactive. Okay, يعني قلق خاملة ضعيفة. And the fluorine بالعكس, the fluorine is too very strong electrophile. Okay, that meaning maybe it will be duplicate or triplet for the fluorine. It will be a replacement on the benzene ring. That meaning it is too reactive or too volatile, very strong. Now, look, in the general, chlorination, this is the chlorination. If I say to you chlorination of benzene, yes, you say benzene ring, Cl2, Lewis acid, FeCl3, it will be give you chloropenzene, خلاص. Okay? If I say to you bromination, Br2, FeBr3, bromopenzene. The mechanism, the same mechanism. Look to the mechanism here. Look, the same mechanism. This, it will be open to the Br to give you the carbocation. Carbocation, 3 resonance, 1, 2, 3. And finally, the nucleophile attack the proton to give you resonance structure again. Okay, I explain step by step. Now, he said here, look to the bromine. In a bromination here, the Lewis acid FeBr3 react with the bromine. That meaning the first step, طلبة, the bromine react with the Lewis acid. Okay, this is the first step. To make for you complex, this is the complex. Br. Why this positive, Sakvan?
بجنة
تبجنا.
لون
Nuka, halogen, monovalent, divalent, tetravalent.
تفكري
يعني هالوجين ايك بوند اند دو بوند بحاله عاديه.
ايك بوند.
ايك بوند هكا دود بنا بوزيتيف.
فما سادم رفشت بيشت مثلا فالنس الكترونجي بترنش او الكترون تراخو دوري.
ايه درسته بس نوكا دايفالنت هكا دايفالنت يعني loss electron to make a new bond. Okay, loss electrons. Okay, if you say loss electron, that meaning number of a proton, it will be excessive from the number of electron, it will be positive. I know that. Yes. تمام سكفان؟
درسته.
Okay, درسته. Now, if I say to you oxygen is divalent, tetravalent, monovalent. What is the oxygen?
Divalent.
عافية, divalent. Now, if you make for the oxygen a trivalent, that meaning the oxygen will be positive or negative?
Positive.
عافية, positive. Then, if you make the oxygen monovalent, egg bond, the oxygen will be negative or positive?
Negative.
Yes, exactly like that. خلاص. Okay. Now, the halogen is monovalent. If you make a new bond with the halogen, that meaning the halogen must be positive charge. Okay, must be positive charge. Now, this halogen, this alkytrophil or nucleophile? This halogen. Alkytrophil, yes, alkytrophil, positive charge, alkytrophil. That meaning the benzene ring, it will be attack. This bromine, it will be attack the alkytrophil. Okay? Now go to the next step. Look, the pi bond, it will be open, and this, it will be added to the positive charge. And then to give you what? To give you, look, Br, and we have Fe here, Br3. That meaning Fe, Br4. This FeBr4 minus or positive?
Minus.
Minus. That meaning nucleophile or alkytrophile?
Nucleophile.
Nucleophile. That meaning this nucleophile, it will be used for the final step to remove the proton. Okay, this is the negative. It will be attack this proton to make for you again the resonance structure. Yes?
Yes.
I hope you understand this. Look to the again to the second step, the pi bond, it will be open to attack the brom. This the sigma bond, it will be equal the positive charge to give you this part Br FeBr3. That meaning FeBr4 minus. Now, where is the alkytrophil? Here, the alkytrophil. Now, it will be happen. We have carbocation. Carbocation. This is stable or no? Yes, it's stable. Why? Because we have additional two resonance structure, this and this. Okay, that means pi bond convert to here positive, it will become to here. Pi bond convert to here positive, it will become to here. Finally, we have resonance stabilize the carbocation. Resonance stabilize the carbocation. The final step, the base or the nucleophile, it will be attack the proton to come back the resonance structure again. Okay, we have again resonance structure, aromatic system again. All طبعا طلبة all the reaction step number 2 or 3 the same step, there is no different. The different, it will be just happened in the nucleophile here in this part. Okay, in this part, look, just here. But all of them we have carbocation, resonance for carbocation. Final step, the nucleophile attack the proton to give you the aromatic system again. Now he said draw detailed mechanism for the chlorination of benzene. Look, he said chlorination of benzene, yani Cl2 and FeCl3. That meaning just replace here the brom with the chlor. Okay, this is the homework. Just replace the chlor with the brom. it will be the same mechanism exactly, just replacement of the chlorine with the bromine. Yes, this is the same mechanism. Look to the nitration again. Nitration of the unsulfonation. He said we take it both of them together because no problem. Both of them, we have the nitric acid react with the strong acid. Look, NO3 nitric acid طلبة. Okay, H2SO4 sulfonic acid. Look, the nitric it will be react with the sulfonic. Look, this and this. Now, if you go to the acid, طبعا the sulfonic acid is stronger than nitric acid because the sulfuric acid is stronger than nitric acid. That meaning this it will be react as acid and this it will be react as base. Why? Because we have unsharp electron on the oxygen. That meaning this unsharp electron on the oxygen, it will be take the proton from the sulfuric acid to give you what? To give you oxonium ion. This is the oxonium ion. Oxygen with positive charge. This oxygen with positive charge, it will be equal by removing this sigma bond to give you the allytrophil. This is the allytrophil. NO2 plus nitronium ion. طلبة nitronium ion. This nitronium ion. This is the allytrophil. That meaning the first step is acid-base reaction to give you what? To give you the nitronium anion. This the nitronium ion. Okay. Structurally, it will be like this: oxygen double bond nitrogen, double bond oxygen, and the nitrogen here positive. Why the nitrogen here positive?
Because have for the fiber.
عافية. Because the nitrogen is a trivalent. When the nitrogen it will be tetravalent, that meaning it will be take positive charge because losing of the electron. Okay, because the losing of the electron. Now the nitronium ion, it will be react with what? With the benzene ring. Okay, look to the second step. Where's the second step? Here. No, where is? Just 1 minute. Okay. The second step must be. Where is the second step? Okay, it must be like this exactly, but I don't draw it. Why? Yes, this the second step. This the second step. This pi bond, it will be open to attack the nitronium ion. Okay, that meaning it will be positive charge here, and okay, we have resonance. Look, a plus 2 more resonance structure. Okay, this related with you can draw the resonance structure. Finally, the base, the negative charge, it will be attack the proton to make aromatic system again. Okay. Then if we go to the sulfonide, look to the sulfonide, and the sulfonide, SO3, it will be react with the sulfuric acid. And it will be give you like this, the unsharp of electron, or this the pi bond, it will be open to attack the proton to give you this, to give you the allytrophil. This is the allytrophil. Okay, this is the allytrophil, SO3H, and this is the nucleophile. This is the nucleophile. We need it in any step, in the final step, in the third step. Okay, and this it will be react with the benzene ring. Where is the mechanism here? Exactly like this, طلبة, but where is it? Okay, I will make the mechanism now. SO3H. Okay, SO3H. It's exactly like this, but replace the NO2 with the SO3H. I will make for you this, the SO3H by ChemiDraw. I will use ChemiDraw. Look. Now, the SO3H. Okay. I will make sharing. Do you see this? Do you see this?
Yes.
Okay. Now, I will make for you this. Okay. Now your allotrophil it will be طبعا طلب sulfonyl. This is the sulfonyl. We have 1, 2, 3, 4, and like this. What we have here? We have oxygen. Yes, Sagvan? And here oxygen, and here sulfur, and here oxygen, and here proton. طبعا we have positive charge here. Okay. Now the pi bond. This is the pi bond. It will be attacked. Look. No. بالعكس.
Attack the electrophile.
Yes. This it will be attack the positive charge. Okay. To give you what? To give you this. 1, 2, and we have positive charge. And this it will be one of them is the proton. Sorry, this is the proton. And this exactly this part or this part, it will be come to here like this.
Without charge.
Okay, but without charge. Like this, exactly like this. Finally, you have the base. طبعا our base is what? Our base is HSO4 minus. Yes? H. This طبعا HSO4 minus. This it will be attack the proton. This it will be attack طبعا بالعكس لازم. This it will be attack the proton from here. Attack this proton. Okay. And this make aromatic system again. Okay, it is clear?
Yes.
Yes, exactly. I will make go back to exactly like this. Exactly like this. No different. Okay, just the different is the allotrophil for the sulfonation and nitration. Just the where's the different? The different in the first step. How the allotrophil it will be formed. The neutronium ion, also the sulfonyl cation. Now he said draw stepwise mechanism, sulfonation and alkyl bases such as A. Here, draw the mechanism from this homework طلبه for you. Just I want from you to draw the mechanism by your hand طلبه again 1, 2, 3 times, 4 times. Okay, it will be easy for you. So easy. بله يا سكبان؟
مش هذا homework يا أوصى.
Anyone?
هذا problem هجده point شو.
No, just a problem. You take it just a problem. This is from book. This is from book. You take it just a problem. Okay, don't care about the number here. Okay, don't care about the number. Just take it. بله؟
هروكية با سری حل بنانه.
ايه هروكي سريع.
بس تيدا ما أبا بيرا بنزينا بيتلق.
كيش؟
أبا هما أي.
ايه I'm not قلتي تسمية. I'm not قلتي تسمية. يعني I want the mechanism. تمام. ده بنزين دي بنلق بيري. هكذا دي بنلق يعني رياكشن نينا. رياكشن هيا. اوكي؟
قال بنزين رياكشن قاعدة.
يعني reaction will be happened on the benzene ring. درست لق it will be happened on the لق يعني no problem.
يعني اللق باز قوفة الويري ما بتشوله بينوكين.
يا أبا؟
يعني بشقاها ما باز بالشكل يالويري.
إيه بس بالصويري. أو reaction هميدي بنسر سر benzene ring. Okay. Now.
يعني سيدة شوي هيدروجينوي راخي بين أو عرض أو زنجيرة ببنى.
إيه أو زنجير حسب كهكي بس هيدروجين. أوكي.
يعني دشور ساروي لكن سيدة.
العفو شيء؟
شو لما دي ساروي راخي بيتأوي زنجيرة ببا أنجي راخي دي.
طبعا طلبة هكا تبنزين هيا وبنزين لقصر بنزين تدا يعني we say substituted benzene ring that meaning the group can be effect. If you say sulfonyl that meaning your sulfonyl group it will become to the ortho or meta or para. طبعا this it will be in the next lecture. It will be different. Maybe the sulfonate will be happened here or here or here. We have rule. We have activate or deactivate group. أو تشتكي دي إن شاء الله for the next lecture. But now the reaction it will be happened on the para. Why on the para? Because this is activation group and make the direction of the electrophilic substitution on the para. Okay, on the para. He said here on the para, he draw for you the product, but he want the mechanism. Just write the mechanism. Okay, just write the mechanism. Okay, but we will talk about these cases in the next lecture, inshallah. There is a rule. We will take it about the substitution benzene compound. Now, Friedel-Crafts alkylation and Friedel-Crafts acylation. Look. The general here in the Friedel-Crafts alkylation treatment of the benzene with alkyl halide طلبة. This alkyl halide, okay, alkyl halide and Lewis acid. Okay, if you use again, if you use Cl, that meaning this AlCl3. If you use this Br, that meaning AlBr3. Okay, this reaction is an alkylation because it is result in transfer of the alkyl group from one atom to another. That meaning replacement the hydrogen by alkyl group. We say alkylation, okay? It will be like this. And for example, look, we have benzene ring react with CH3, CH2Cl, AlCl3, that meaning the product it what? Alkylation, that meaning the R group, it will be CH2, CH3. Okay? Now, if your R group this, CH3 by 3C, okay, that meaning your R group it will be here, this your R group. What is this R group? Tertiary what?
Butyl.
Okay, tertiary butyl. Okay, and طبعا HCl, if you use Br, HBr, no problem. طبعا the mechanism, the same mechanism, just we have different in the first step. How? The RCl, the alkyl halide, it will be react with the Lewis acid. Where is the Lewis acid? Look here. And this is just example here. Acid chloride, this is the acylation. Acid chloride, Lewis acid. That meaning this your acyl group. Look, acyl group. Okay. If you use CH3 carbonyl chlor, that meaning it will be carbonyl CH3. Okay. Look to the mechanism, the first step. The alkyl halide, it will be react with Lewis acid. The same thing. The antipophilic electron of the halogen, it will be attack the aluminum atom. Okay. To give you the electrophile. This is the electrophile. Okay. This is the electrophile. Okay. Now for the first step, I think here. Yes. And then the electrophile, where is? Here. طبعا. Look. Now, this electrophile, yes? This positive charge. Now, if I told you this sigma bond, it will be open to the halogen. That meaning this, it will be primary carbocation or secondary or tertiary طلبة. صقبان غسق منو عندنا؟
أستاذ شلون أعيد السؤال؟ لأن
أعيد السؤال. No. شوفي. We have alkyl halide. This alkyl halide, yes?
Yes.
Okay. Alkyl halide react with AlCl3. تمام؟
تمام.
ايش راح ينطينا أول خطوة؟
الكتروفيل.
The electrophile. زين, the electrophile. We have additional step or no?
عندنا.
زين, عندنا. تمام. زين, if for example, if we open this sigma bond, open to the positive charge, on the positive charge, that meaning the positive, it will be converted to here, yes?
Yes.
This, if I say to you carbon positive charge, this carbocation or primary or secondary or tertiary, anyone?
Primary, yeah?
Primary. Then, Hanzana primary stable or no?
Not stable.
Yeah, not stable. That meaning it will be not opened. This bond, it will be not open. Don't make for you primary carbocation. It will be react like this. Exactly, it will be react like this. Okay. Now take this example. Look, this CH3 by 3 carbon chlor react with Lewis acid. Look, it will be give you this allytrophil. Yes. Now, if I open this bond, it will be give you what? Carbocation. Any carbocation this?
Secondary.
Yeah.
Tertiary.
Yes, tertiary carbocation. Tertiary carbocation stable or no?
Stable.
Stable.
Oh, stable. A stable carbocation, that meaning this carbocation, it will be react with benzene ring like this, not like this. Yani, the benzene react, it will be react with the tertiary carbocation, not with this. Okay? Now I give you example.
primary debaking.
هكا primary لازم this bond it will be don't open. Okay, if the tertiary, that meaning this bond it will be open. Okay, I will give you example now to know the problem. Look to here. For CH3, this is also important طلبة. For CH3Cl and the primary alkyl halide, Lewis acid base complex, this Lewis acid base complex, this and this. Okay, he mean this. Lewis acid base complex itself serves as allytrophil for the allytrophilic aromatic substitution. That meaning, in this case, this it will be allytrophil though for the aromatic substitution reaction. But in the secondary and tertiary alkyl halide, if you use secondary and tertiary alkyl halide, Lewis acid base complex react further. Look, we have additional step, react further to give you or secondary or tertiary carbocation. This the secondary or tertiary carbocation. This it will be entered to the allytrophilic substitution with the benzene ring. Okay, which serves as the allytrophil. Carbocation formation occur only with the secondary and tertiary alkyl chloride. Why with secondary tertiary alkyl chloride? Because the secondary or tertiary give you secondary tertiary carbocation. Secondary tertiary carbocation stable carbocation, not stable. Okay, it will be stable. If I say to you stable carbocation, يعني suitable, يعني ملائم, يعني مناسب to enter to the allytrophilic substitution reaction. Okay, because they afford more stable carbocation. And now I will look here. Now look, this tertiary carbocation. This is tertiary carbocation is stable to react with the benzene ring, stable to enter to the allytrophilic substitution aromatic reaction. Okay, that meaning the first step make the tertiary carbocation. Tertiary carbocation is allytrophil. The pi bond it will be attack the allytrophil. It will be open to attack the allytrophil to give you this intermediate. This intermediate طبعا طلبة we have resonance here. We have two more resonance structure. Now we have a base here. The base it will be attack the proton. Okay, and this both of the electron of the sigma bond between carbon and hydrogen it will be open to make a new pi bond, and our aromatic system it will be come back again to give you alkyl substitution. Alkyl substitution. This reaction is alkylation. Okay, the same thing for the acylation. Now he said here addition of the allytrophil tertiary carbocation form a new carbon-carbon bond in the step number 1, and finally this step remove a proton from the carbon. Okay, from the carbon this to remove the positive charge to make a pi bond again to come back aromatic system again. And what we have here. Okay, yes, I think it is clear now. Do you understand this, طلبة? Ragban, Rasab,
السيدة
استعمال.
هاكر برايمري بدي يعني نامي نتبويري
هكا برايمري نا او الكتروفايل او الكتروفايل دبنا افيا عفوا 1 minute دبنا افيا يعني benzene ring this benzene ring it will be attack this
يعني
Okay,
بوتشناب
بوجي تشناب تشنكو هكا
راح
stable
نبقى هيك يعني ما نلعب بيه راح نخليها هكا.
سيدة كروماتيك
ارسم لكم اياها
سيدة
اسمع.
كروماتيك
يعني بعد ما اكو تفاعل لي حد هون يقف.
لا اكو تفاعل بس ارسم لكم اياها بس لحظه علي. اوكي هاي المشكله الرسم بالكيمو اوفيس يحتاج وقت يعني. What we have here, we have, for example, CH3, and again, and we have what we have here, halogen. 1 minute. This CH3, CH2, like this, yes. And what we have here, we have chlor, Cl, and here what we have, Al,
AlCl3
Cl3, and we have positive here, yes. Now, the reaction it will be the ring of benzene ring. It will be react with this, okay, with this. That meaning how it will be. This it will be look. This pi bond it will be open to attack this, and this bond it will be convert to the Cl, okay. That meaning our product it will be how this it will be our product. Look, this our cycle here, and we have here 1 2, and we have 1 2 exactly like this. طبعا طلب this no, sorry, we have one excess. This it will be what? It will be CH2, and this it will be CH3 plus what? Plus يلا plus what?
AlCl4
اي عافية AlCl4 minus. اوكي يعني Cl ابا Cl و Al sorry AlCl3 اوكي ماينس طبعا هذا ماينس او ماينس بوشية مهمة بو next step بو next step this nucleophile it will be attack what
hydrogen
عافية it will be attack this proton ابا very ابا نايتا ابا very sorry دوستا it will be attack this proton and this sigma bond it will be convert to make pi bond again. You understand?
عارف سيدة.
اوكي الحمد لله. That meaning غسق في حالة استخدمنا primary alkyl halide هذا الكومبلكس هو راح يتفاعل مع حلقة البنزين. في حالة استخدمنا secondary وتيرشري لا راح يصير عندنا كاربوكيشن والكاربوكيشن راح يتفاعل مع البنزين رينج. تمام؟
تمام.
وعفوا وسق وين راحت؟ هي كانت من السؤال. اوكي تمام. ستير تمام؟ سقفان طلبة همي
درست سيد
طلبة همي قال ما عن شي عرضك دي
يا استاذ معك ايه
اوكي دوشة معي لو ما معي
يا استاذ تعرف سديت المايك كان صوتي يمي
كادلين معنا كادلين دلين ما موجودة هافين جنان ليلى
بله سيدة
بس اكفيريو يا تشار نيلفير يعني بنجي وتشار طالب از بجم بس نه طالب قلما ويا دي همي اصلا نانك موبايل دي استنى
والله سيدو قالت انا مايكي كتاين قوت سيدو خذ كافتا سري
اوكي تمام. The good thing here for the study online, you can repeat the lecture, okay, many times. This is the good one, يعني. The best thing. Then I don't worry about that.
بس السيدة
استاذ هاي بيها PDF هاي الملزمة معاها PDF.
ما خلينا البي دي اف على الموديل.
ها ما شرط انه لين قبل فتوا على الزوم.
ايه والمحاضرة والقبلة من صار لي قبل أكثر من أسبوعين خليتها على هاي.
سيدة أبا چند ريكورد حدانو که؟
أو ريكورد سيابة.
نه بجم چند ريكورد بوانو که؟ ساعتها که أبا چنده؟
ها أو هشتا ساعتك يعني هشتا.
ساعتك وتشارتك.
أوكي نعم.
دامو بستن.
No.
دي سيدة بس
No. أو محاضرة سي حتى نوكا سلايدز يو هشتا صح كي ملزمة كان بس أو شابتر هشتا وشيش.
سيدة معك أمرو في نوان كريتا.
ما كبوچه كم خلاص كرام تينا گشتين.
نه
سيدة نفس كرسي
ما شاء الله أنت ذاك. إيه. For the acylation طلبة we will go to the acylation. Where's the acylation? Friedrich.
سيدة بتوجد ما بدريجي شرح كي والله سر أبي.
بس بشكل وانا ناس سريع ما كان سريع انتظار شيء يعني لو كان
لازم كل شرح كي ما كيتينو جاي نصدف.
Okay. Now I just want to I think I will stop here. Where is other fact about 3D craft rearrangement? I will stop here. The substituted benzene. Okay. But I take this the final. Just we have final reaction. We have the final one. Okay. I will take just the final reaction and we will stop it to the substituted benzene ring. Now for the acylation طلبة the same thing. The halogen atom, look, it will be react with the Lewis acid to give you this complex. Okay, now this complex, this sigma bond, it will be open to the halogen to give you this carbocation. This carbocation stable or no? Stable. Why? Because we have resonance. This unshapeable electron make the triple bond and the positive will become to here. That meaning we have two resonance structure, make the acylium ion stable. This is the carbocation. Now, our electrophile, this our electrophile. That meaning the benzene ring, it will be attacked with this. Okay, with this. Attack with this. Again, our benzene ring, look, the benzene ring, it will be attacked. This carbon is our electrophile. And the same thing, the nucleophile, it will be attack the proton to make aromatic system again. The same mechanism, look, for the halogenation, for the alkylation, for the acylation, for the sulfonation, for the nitration, the same mechanism, طلبة. 3 step, 2 or 3, the same step. Just the step number 1 to give you the electrophile is the different between of them. And the other, step number 2 and the same mechanism, there is no different. Look, the same mechanism. Now he said here, other fact about the Friedrich craft alkylation. Look, طلبة, if we could go back again to this. No, to this, sorry. To this. We said here carbocation, tertiary carbocation, yes?
Yes.
Tertiary carbocation rearrangement هي and na. Nina. Okay, because tertiary carbocation. But if you use secondary alkyl halide, this secondary, give you what? Give you secondary carbocation, yes?
Yes.
زين secondary carbocation طلب بس هي شاربن فيري. هكا rearrangement هي تشيكن. اوكي؟ هكا rearrangement نينا دعيناك تشيكن. اوكي؟ يعني هكا secondary carbocation احتمال هي دبنس tertiary carbocation you have to do it. Okay? هكا rearrangement نينا no problem. You can enter to the secondary carbocation to the reaction. Now this we talk about some fact about Friedrich craft alkylation. Look, vinyl halide, he said vinyl halide and aryl halide don't react in the Friedrich craft acylation. This is the vinyl halide and this the aryl halide. Why? He said here, most of Friedrich craft reaction involve carbocation. Look, carbocation, electrophile. Vinyl halide طبعا طلبة if don't give you stable carbocation. The carbocation that it will be formed from this vinyl halide, it will be not stable. Also, if you want to remove this halogen to make carbocation on the benzene ring, it will be so not stable. For this reason, vinyl halide and the aryl halide don't undergo or don't react with the Friedrich-Rath alkylation. Why? Because the carbocation derived from the vinyl halide and aryl halide are highly unstable and don't readily form. This organic halide don't undergo Friedrich-Rath alkylation. Okay?
فرقه فينايل هالايد وارايل هالايد هي.
ايه صح كفينال هالايد افيا فينال هالايد. I will make for you sharing this the vinyl halide. This 1, 2. For this the vinyl halide. Okay, sorry. This the vinyl halide. Now this the vinyl halide. If I want to remove this halogen and make positive on the double bond, that meaning it will be like this. It will be طبعا with AlCl3 طلبة with AlCl3 this. AlCl3. Okay, give you what? It will be give you this. It will be give you exactly this. This طلبة positive on the double bond. This not stable carbocation. Okay, this is not stable. تمام. This not stable. If I say not stable, يعني it is not ready to react with the benzene ring. Okay, not ready to react with the benzene ring. تمام, not stable. Now for the benzene, the same thing. If I say benzene, like this, Cl and AlCl3, exactly like this. Sorry. AlCl3. طبعا this, يعني for example this, it will be also the positive carbon on the benzene ring. This carbocation is also not stable. Not stable. تمام. This, both of them give you carbocation. This carbocation not stable. If I say not stable, that meaning it is not ready to enter with the electrophilic aromatic substitution. تمام, واضح سقفان؟
درست سيدة.
درست. This. For this reason, the vinyl halide and aryl halide don't react in the Friedrich-Rath alkylation. Now he said which halide are unreactive in a Friedrich-Rath alkylation reaction. Anyone is unreactive. This reactive or non-reactive?
reactive
Huh?
reactive
لا. أو وكيتشيا معنى وكي double bond halogen. أوجي double bond halogen. That meaning this vinyl halide unreactive. This reactive, no problem, because we have CH2 here. Okay, CH2 here. This unreactive. It is like aryl halide. This
reactive.
Okay, why? Because we have CH2 here. CH2 يعني not aryl halide, يعني alkyl halide. Alkyl halide عادية reactive, مش كأننا alkyl halide. Also this alkyl halide. This aryl halide, this vinyl. Vinyl aryl not reactive. Alkyl reactive. Okay? Now طبعا طلبة بنقول هكا rearrangement هي تشيكن أو rearrangement صح كطلبة. For example, if I give you this benzene ring and this alkyl halide, any type of alkyl halide, this primary, secondary, tertiary, زين secondary هكا carbocation very cheap بو secondary rearrangement هيا أنا
يا هاي
يا
تيرسري استجابي
صح عافية يعني هن وقت التفاعل تشيك النابجن بنزينينج دي ارتباطه قال أو كربون لا خلتها صح أو كربون فيري the benzenic reaction it will be make bond with this carbon. How? Because the rearrangement. I will give you the rearrangement. No problem. Okay? Because the rearrangement. Okay? يعني وقت امتحان طلبة هكذا بس صح تفاعل وصى تتبيجت the product is this. I will make for you the product. That meaning, look, the bond it will be happen between this carbon or for this carbon, no problem, this carbon, anyone, with this, yes? This theoretical, but in the lab, no. Your product it will be this. You say to yourself, how this product it will be formed? طبعا this product it will be formed during rearrangement of the carbocation. Okay, I think I explained this here. Yes, I will take the mechanism. Okay, don't worry, I will take the mechanism. This is the mechanism. Now, look to the primary halide. A primary halide react with this, and we have a product here. What is the product? We have rearrangement here. Okay, rearrangement. That meaning, if we have any probability to make rearrangement, please do it. Okay, please do it. How? I will explain for you. Look. If I convert to the chemi draw. Okay. Now I want yes to go to the mechanism. Okay. Now look to the mechanism, طلبة. This our alkyl halide. Any alkyl halide is secondary, yes? Now, if the alkyl halide react with the Lewis acid, this Lewis acid give you this complex. This complex, if we want to remove this this positive charge, we have to open the sigma bond between the carbon and the halogen. Now it will be give you this carbocation. This carbocation, primary or secondary or tertiary?
secondary.
Okay, secondary carbocation. Now, secondary carbocation, there is any probability to make rearrangement or no? Yes. How? By what? This group, hydrogen galhardu electron. It's been a 1-2 hydride shift. 1-2 hydride shift. أبد بنافيري صح كي؟ This hydrogen galhardu proton it will be convert to the neighboring carbon أو carbon جيران مجاورة. Okay? That meaning give you tertiary carbocation. أو tertiary carbocation. This it will be react with the benzene ring. Look, the benzene ring, the pi bond, it will be attack the carbon, the carbocation to give you the intermediate, and then the nucleophile it will be remove the proton to give you aromatic system again, and your product it will be this your product. Okay, don't make a product you say bond from here this carbon with this carbon, no خلط, because we have rearrangement. Okay, because we have rearrangement. Okay, يعني هكا أزبوطها بنبيسم بس صحكي. 1 minute. نعم.
فإذا بخرج بتأي خطوة محاجة في آخر تشينو نظام تشو.
لا هكا از صحكي هن أهم تشت بسيار يعني you have to understand my question. If I say to you write the mechanism stage by stage يعني تهمي لازم تفصل بالميزة. If I say to you just write the product نا هذا product دوما هيك وخلاص وشو.
Yes.
Okay. Now look plus this plus any compound honey we have CH3 no sorry like this CH3 our alkyl halide this yes or as خلتهم this CL yes this our alkyl halide
CH3 CH2 CH2
like this
درست سيدة درست
I think this okay now طبعا دو احتمال هيا and this Look, you said 1, this, طبعا 2, 3, 4, طبعا هذا very طبعا, and this or this. قالك دير هذا وصل تمام, or it will be this 1, 2, 3. Okay, this or this. Okay, now anyone is right, this or this. شو فرق طلبة أو سكبان يا سري بني صحكي يا سري مباشرة أو كربون صحكي مباشرة أو كربون bonded with this معناه؟ يعني بين rearrangement أو يا سري without rearrangement. يا بني نا يا بني carbon bonded with this and also with rearrangement. Okay, anyone is right. The upper one or the lower one?
Rearrangement.
Yes, the lower one it will be our product. يعني وقت امتحان هكذا بيجمعها هذا بلس هذا بنبيسها خلص صفر. لازم تظني rearrangement هي ومباشرة to draw this product. Our product it will be this. Why? Because the rearrangement. Okay? Because
سيدة
بله سيدة.
سيدة بوش ما rearrangement بو CH3 نتذكر ما بو يتذكر.
ما نسي CH3 العفو تشيا.
منا ما هبو يا R وما هبو يا H shift.
ها. the two يعني you have to use مخيلة your imagination. Look, if we remove you say here if you remove this group all this yes CH3 قال هردوا الكترون معنا.
سيدة أو ساري منا ما نكيا هاي CH3 وبنيجي H ها
إيه طبعا أو CH3 أو CH3 ما هردوا هيك نبنا.
إيه.
تمام مشكلة يعني يلا هذا راكا ودانا فيري دي بدنا كيش كاربوكيشن سكندري تيرشري أو برايمري؟ سكندري يعني سكندري وشو سكندري هنا معقولة أو سكندري شو سكندري بوش سكندري دي شي سكندري عامد فيتن سكندري دي بدنا تيرشري دي بدنا مور ستيبل. تمام؟
بلا سيد
واضح عن هشتا؟
سيدا وانا او CH3 دي شت سيريادي دي بلس شت وجهوي
جهوي بلس زين او بلس جهوي دي بدنا شيء سكندري تيرشري برايمري دي بدنا شيء
سكندري
سكندري يعني هكا سكندري دي بيجي سكندري دعيناك تعمل تشيكن اصلا. عامل بيت rearrangement دي happened كانجي if we formed more stable carbocation. Okay.
سيدة برايمري بو سكندري rearrangement ها واصوجي.
ايه شو معنا او مثال هي هذا ها او برايمري بو سكندري او برايمري بو سكندري. تمام.
واني باقي بالي.
ايه او برايمري دي بنا very carbocation also 1,2 hydride shift دي بنا secondary carbocation by secondary carbocation reaction with benzene to give you this product. Okay. بط طلب يعني بتشك تدريب المال يعني صار ورقه وقلم يعني بتشك بنفيسن. اوكي
خلاص.
we are here the substituted benzene. طبعا طلب انه our reaction just with no substituted benzene. Look, we take it all our reaction no substituted benzene like this no substituted benzene. Okay, no just benzene ring. Just benzene ring. We talked about just benzene ring. No, next lecture inshallah we will take the substitute benzene. يعني هكا كمثلا سر بنزين لقك هي and دلق هي. Okay, what will be happen? Where is your new group? It will be like this. Now we will talk about that inshallah next lecture, and if you don't have any question you can